you're going to write properties of the real number system. Okay, properties of the real number system. So what are you doing today? Today you're learning, well, not just this. We're going to talk about something else. We'll erase it and replace it with something completely different. But today you're going to be learning how to identify and also how to use the properties of the real number system. So we're going to start with what we call the commutative property. Okay, and we're going to divide this into two columns, addition and multiplication. Let's see. Okay, so what does the commutative property say? The commutative property says that A plus B is the same as B plus A. It also says that A multiplied by B is the same as B multiplied by A, so you can see. Let's put numbers in. So maybe 3 plus 5 is the same as what? 5 plus 3, which is obvious. 3 times 5 is the same as what? 5 times 3. Okay. Big deal. What is this saying? Okay, so 3 times 5 is 15, 5 times 3 is 15. We know this. But commutative property, what does the word commute mean? Commute means to simply change location. So if you commute from what? From school to home, what did you do? You changed what? You changed location. So if we look here, notice that your numbers just simply change location. Here we have 3, 5. Here we have what? 5, 3. Okay? Here we have 3, 5. Here we have 5, 3. So it's a matter of changing the order of the numbers themselves. Okay? Next property says, we call it the associative property. Associative property of addition says that A plus quantity B plus C is the same as quantity A plus B plus C. Multiplication says A times quantity B times C is the same as quantity A times B times C. And what is this saying? Okay, so let's put in numbers. 3 plus quantity 4 plus 5. Same as quantity 3 plus 4, add 5. Or basically it's saying multiply 4 and 5, then multiply by 3 is the same as multiply 3 times 4, then multiply 5. Okay? So before we go any further with this, I want you guys to, don't write this down, just listen. Please excuse my dear Aunt Sally. How many of you guys were told this lie? Okay, this was one of the worst acronyms ever introduced before you reached algebra. Let's cross this out. We're going to replace it with please excuse my aunt. So my emphasis here is how many operations do we have in math? There are 2. Simply addition and what? Addition and multiplication. That's all. So you say, well, hold on. Isn't subtraction different than addition? Well, you do. Okay, let's look. 9 subtract 5. All right, okay, you know how to read this as 9 subtract. And we will say this in class. We're not just going to call everything addition, everything multiplication, but I want you today to see that subtraction is nothing more than what we say the inverse operation of addition. So we say 9 minus 9 minus 5 is 4. We can rewrite this as 9 plus negative 5. Okay, so you see that 9 plus negative 5 is also 4. That subtraction is nothing more than adding the opposite. Similar with multiplication, division, if we say 15 divided by 3 is 5, we can say, change the division to multiplication, right? 15 multiplied by 1/3 is 5. So we see that division is nothing more than the operation of multiplication of the reciprocal. Okay, so yes, we will talk about, we will say division, we will say subtraction, but I want you guys to think in terms of how many operations are there in math today? There are just, 2, addition and multiplication. Everything, whenever we talk about subtraction, we're referring to what? Addition. And when we refer to when we say division, we're referring to multiplication, or let me say it like this. Addition covers addition and subtraction. Multiplication covers multiplication and division. Okay, so what is this? Okay, here, parentheses. What do we do first? Parentheses. What is this saying? Notice 3, 4, 5. 3, 4, 5. In the commutative property, numbers switch location. But in the associative property, notice 3, 4, 5, 3, 4, 5. The numbers did not change location. What is this? This is a regrouping. What does the word associate mean? Okay, associative, associate. If I associate with so-and-so, then that means that I hang out or I group up, or the word associate means to group with, to hang out with. Notice 4 and 5 hanging out here, 3 and 4 hanging out. What do we do first in this acronym? The acronym says we do what? Parentheses first. So here we're doing 4 plus 5, so we get 3 plus 9. And here we get 3 plus 4. We do the 3 plus 4 first. We get 7 plus 5. Notice 3 plus 9 is 12. 7 plus 5 is 12. We get the same thing. And here, 4 times 5. 4 times 5 is 20, so we get 3 times 20 here. 3 times 4 is 12, so we get 12 times 5. And hopefully you agree that 3 times 20 is 60, and 12 times 5 is also 60. So you see that it doesn't, what this is saying is it doesn't matter the order in which we add. So notice the numbers did not just change location, but we reordered the operation of addition. So we add the 4 and the 5, then add 3. Here we add the 3 and the 4, then add 5. So it's a matter of reordering the operation. Now, when you write the answer to, if you're asked to name these properties, you don't write commutative property. You write what? This property is called the commutative property of what? Addition. This property is commutative property of multiplication. This property, associative property of addition. If you write associative property, you lose a point. Okay, so you will write the entire name of the property, associative property of addition. Okay, so don't call it just the commutative property, but we're going to tell me, is it the commutative property of addition, or is it the commutative property of multiplication? Okay, now next, identity. Identity property. Identity property says that A multiplied by 1, this is addition. A plus 0 is A. And the identity property of multiplication says that A multiplied by 1 is A. Okay. Or similarly, we can say 5 plus 0 is 5. Or 5 times 1 is 5. Okay. So basically, identity, that's obvious. Okay, here's my ID. Okay, my ID represents another representation of me. So here's my ID, here's me. Okay, so start with me, end with me concept. You start with A, you add 0, what did you end with? A. You started with 5, add 0, what did you end with? 5. You start with 5, what do you end with? 5. Okay, so 5 plus 0 is 5, 5 times 1 is 5. Okay, so whatever you start with is what you end with. I also want you to write this down as a side definition. Circle your 0 and circle your 1. 0 has a special name. 0 is called the identity element of addition. Meaning, identity element. Identity element is a number. Identity element of addition. This means whenever you add 0, you get the same thing. So you have what? 5 plus 0. 5 plus 0 is 5. 7.2 plus 0 is 7.2, or 168 plus 0 is 168. Under the operation of addition, think of addition as its own entity. Under this entity called addition, under this operation, when we add 0, we get the same thing. So no matter what you have, car plus 0 is car. If car were in the set of things that could be operated under addition, so in this case we're dealing with numbers, but so 5, the number 5 adds 0, you get 5. Any number, A, add 0, you get the same thing. So 0 is called the identity element of addition. Number 1, this is the what? Identity element of multiplication. Obviously meaning, just like 0 is for addition, when we multiply by 1, we get the same thing. So 5 times 1 is 5, 7.2 times 1 is 7.2, and etc., and you get the point. So make sure you have this down. This is also on the quiz. So when I ask you, what is identity element of addition, you write what? 0. It's a number. Identity element of multiplication, what do you write? You write 1. It's a number. Next, inverse. Inverse property. And this is A plus the opposite of A is 0. Or A multiplied by 1 over A is 1. Basically notice what we're ending with. We're ending with what? The identity element. We're ending with what? The identity element. So inverse. Inverse says that if you have a number 5, what you have to add to it to get 0, you add negative 5. So 5 plus negative 5 is 0. Identity property of multiplication says that 5 multiplied by 1 over 5 gives the identity element 1. So when you're trying to identify these two properties for a minute, let's talk about some clues as to identify inverse. Students get these confused all the time. Inverse identity. What are some clues to identify these properties? 1s and 0s. You see 0, you see 1. So when you see 0, you see 1. you know that you're looking at either what? Identity or inverse. So let's look at some examples. If I write negative 3/7 plus 3/7 is 0, hold on, so what did I say? Identity. What do we to do identity? We look. What did we start with? What did we? So we started with 5. What did we do? We ended with 5. Okay. With here, notice we started with what? We started with negative 3/7. Did we end with negative 3/7? No. Okay. So this is not identity. This has to be what? Inverse. How did you know one or the other? Because of the 0. Okay. So if you see 0 or 1, you know that you're looking at identity or inverse. So since you start with negative 3/7, you did not end with negative 3/7. This is not identity. This is what? Inverse property. Let's say negative 3/7 multiplied by negative 7 over 3. What do we do? Multiply negative 3 times negative 7. We get what? 21. 7 times 3 is what? 21. 21 divided by 21 is 1. Okay, so you see the 1. Okay, 1's a clue. Identity or inverse. We started with negative 3/7. Did we end with negative 3/7? No. Okay, so this is not identity. This is what? This is inverse. This is the inverse property of, how do we say this correctly? We say inverse property of what? Multiplication. Okay, so this is the inverse property, name the operation. Multiplication, this is the inverse property of addition. Now, negative 3/7 add 0, we get what? Negative 3/7. So what did I say? 1s or 0s, we look for clues. 1s or 0s mean identity or inverse. We started with negative 3/7, what did we end with? Negative 3/7. This is what? This is identity property of addition. If I say negative 3/7 multiplied by 1 equals negative 3/7, you started with negative 3/7, you ended with negative 3/7, so therefore this is what? Identity property of multiplication. Okay? Again, when you name these properties, you name them as associative property of what? Associative property of addition, associative property of multiplication. Lastly, last property of the real number system we're going to look at is called the distributive property. And this is the most important of all the properties we will look at today. Okay, so we're going ahead and write this down. Distributive property says A multiplied by quantity B plus C is the same as AB plus AC. What is this saying? Okay, we don't call this the distributive property of addition. We do not call this the distributive property of multiplication. Notice that it's written outside of these columns, okay? Notice, here we have multiplication, here we have addition. The distributive property is the property that relates what happens when multiplication meets addition. Okay, so when multiplication meets addition, what happens? The distributive property applies. Okay, so we look at here, 3 times quantity. 3 times quantity x plus 7. Okay, so we distribute. And 3 times x is 3x. 3 times 7 is 21. Okay, so the question is, did the 3 distribute? Did the 3 distribute? No, the 3 did not distribute. What distributed? The multiplication. Okay, this is an operational thing. What distributed? Here we have 3 multiplied by the quantity x plus 7. So you have multiplication, you have addition. What distributed? The 3 did not distribute. What distributed? The multiplication distributed over what? The addition. Okay, so we say multiplication. What happens when multiplication meets addition? The multiplication distributes. Okay, so we look at this. We can also look at this backwards. You have to be able to see it both ways. Let's look at AB plus AC. This is also distributive property. Is the same thing. We can take the A back out and say that this is A times quantity B plus C. Here, I will help you see it. Okay, so if we distribute, okay, you see we took the A, the common A, out. Okay, so say maybe, let's look at this as 3x plus 21. What divides 3 and 21? 3. Okay, so we're going to take the 3 out, and what's left? Okay, so we say 3 times what, or divide by 3, x is left. What's 21 divided by 3? 7. Do you see it? So 3 times x is 3x. 3 times 7 is what? 21. So you have to be able to see this going forward. You have to see this going backwards. So you say, what do you mean multiplication distributes over addition? I will show you. Okay, the distributive property is everywhere. Once you start to understand this property, you start to understand or unlock, I should say, the mysteries of this subject, algebra. Okay, so this is going to be your struggle this semester. Students struggle with distributive property. And hopefully you will be paying attention to when it pops up and notice how do we use this property. It comes in many different forms. Watch, here's one example. So if we write 3x plus 8x, you were told by your previous math teachers that when you add like terms, Okay, you just simply add like terms. Here, 3x plus 8x gives what? 11x. Just do it. Okay, so you took this for granted. 3x plus 8x is 11x, and we're happy. But what is this? Do you guys look clearly? Clearly, we see here that this is 3 multiplied by x and 8 multiplied by x. Do you guys see multiplication and addition in the same problem? Okay? So when multiplication meets addition, what property applies? Distributive. Okay, so what is this an example of? This is an example of distributive property. It's not 11x because you were told that it was 11x, but it's 11x. Why? Because the property tells us that this is 11x, not because your teacher told you. Watch. Okay, so we say, here, if you don't see it, let's write. So we say 3x plus 8x, what's common? X. Okay, so we can do what? We can take the x out, and what's left? 3 plus 8. Do you see? You see x distributes. Well, the multiplication distributes. So x times 3 is what? 3x. X times 8 is what? 8x. There it is. So how do we have 11x? Because take x out, that's 3 plus 8. This is what? 11x. Okay, so this 3x plus 8x is 11x, or you add like terms. Why? Because of the distributive property. Okay, so these are the properties of the real number system. Fill the board space. Okay, so we're going to have to erase to do the next set of properties. So make sure that you have these down. And you may pause the video if you're not done writing. Okay? All right, I'm going to take these off. Okay. Next set, we're going to call these, and these are different, we're going to call these the properties. So I guess I should have been more clear. We're going to learn today how to use properties of the real number system, also properties of equality. So these are completely different. Properties of equality. Now, first property, so go ahead and write in your paper R, S, T in order. This helps. Okay, so you remember R, S, T, alphabetical order. You maybe think of this as simple, moderate, complex. Okay, not really, because transitive property, what we're going to get to down here, it's actually probably the easiest of the three for most students. So simple, medium, complicated, maybe takes longer to write it. Okay, so R stands for reflexive. Let's see. Reflexive what? We're going to call this the reflexive, not reflexive. If you write reflexive, you get, what, 50%. This is the difference between 50% and 100% on the question, guys. You don't write reflexive, you write what? Reflexive property of equality. Okay, so this is a property of equality. You write the entire name of the property, reflexive property of equality. Told students this all day. Okay, write the entire name of the property. And what happens? Half of them are writing just what? Reflexive. Okay, so you must be reminded. Make sure to double check. Reflexive property of equality. And it's, oh, I forgot. Okay, all right. So just make sure you write the whole name of the property. Reflexive property of equality says that A is equal to itself. That's it. That makes sense. Okay, something is equal to itself. So for instance, 7 is equal to 7. Okay, what else? Maybe A plus B is the same as what? A plus B. Okay, so something is equal to itself. Very simple. Intuitively obvious. Next property. This is symmetric. Okay, again, symmetric what? Symmetric property of equality, okay? All right, so symmetric property of equality says that if A is equal to B, then B is equal to A. Basically, if the first is the second, then what? The second is the first. You turn the equation around. For example, if 0 is less than let's do this. 0 is equal to x squared plus 5x plus 6, then what? We could turn the equation around. Okay, we can say what? Divide the equation into 2 halves, the equality. We can put what's on the left. Okay, equations have two sides, guys, the left side and the right side. So 0 is on the left, x squared plus 5x plus 6 is on the right. And so we're going to take what's on the right, put it on the left, what's on the left, put it on the right. So we're going to have what? In this case, we're going to say x squared plus 5x plus 6 is equal to what? 0. So we can turn the equation around. Now, I said that and it's not up here, but I said that the distributive property was the most important and most used property in this class. This is probably the second most used property, and the one I was talking about a whole lot as the semester goes on. We'll use it because it's hard to look at this. But if we turn it around, it's easier for our eyes to look at it. See, x squared plus 5x plus 6, x squared plus 5x plus 6 is 0. Okay, so what does symmetric property say? If the first is the second, then the second is the first. We can take it and turn it around. So we can flip an equation. Okay, next. Transitive. Transatlantic flight. Okay, transatlantic flight means what? Across the Atlantic. Okay, transitive. Transfer is across. Okay, transitive property means what? Across something. Okay, transitive is a transfer of equality. Or, let's see what this says. Okay, so across equality is what we're going to be looking at. If A is B and B is C, then A is C. What this says is if the first is the second and the second is the third, then the first must be the third. Okay, so let's get an example here. All right, so x plus 2 is equal to y minus 7. And y minus 7 is equal to z plus 13. So we see here, notice if the first is the second and the second is the third, then what can we say? If the first is the second and the second is the third, then we can say that what? The first is the third. So we can conclude, 3 dots mean therefore, we can say that x plus 2 is equal to what? Z plus 13. Okay, so if the first is the second and the second is the third, then the first is the third. Okay, makes sense. Like I said, students generally find this property to be one of the easier of the three. Okay, now, what's the clue that you're looking at properties of equality? You'll notice that these properties, different from the ones that we previously wrote on the board, when you're dealing with properties of equality, here's the clue. If, then. When you see the words if, then, you know that you're looking at probably a property of what? Probably a property of equality. Okay, so pay attention to the words if, then when you guys take the quiz. If you see the words if, then, you're probably looking at a property of equality. There are two more. We have addition, and we have multiplication. Okay, so what does the addition property of equality say? The addition property of equality says, maybe more room here. And again, how many operations do we have in math, I guess, today? We're thinking in terms of what? 2 operations, okay? Just simply addition, multiplication. When I say addition, I'm referring to what? Addition and subtraction. When I say multiplication, multiplication and division. Okay, so addition property of equality says that if, again, we see if, then. Okay, so if x minus 7 is equal to 5, then what can we conclude? Okay, now if you look at this, remember equations have 2 halves, a left half and a right half. What we do to one side, we can do to the other. So if we want to get x by itself, notice that 7 is being subtracted from x, we can simply do what? We can add 7 and add 7. So we end up with x equals what? 5 plus 7 is 12. Okay, now this is not going to be there. You're going to have to look at the property this way and see it. Okay, so you have, if x minus 7 is 5, then x equals 12. So what you ask yourself is, what happened on both sides of the equation? Notice that 7 is now gone. So what happened on the left and the right side? 7 was added and what? 7 was added. So you would call this the addition property of equality. Okay, so let's look at the next one. I'm not going to write it in. See if you can see it. So if 3x plus 5 is equal to 14, then 3x is equal to 9. Okay, what happened? What happened? If you look here. Okay, notice here we had 3x plus 5. Now we just have 3x. You have to ask yourself, what happened on the left? 5 was subtracted. Okay, look at what happened on the right. 14 minus 5 is also 9. So 5 was subtracted, 5 was subtracted. I said the subtraction is the same as addition. So if you see 5 was subtracted, 5 was subtracted, we call this what? We call this the addition property of what? Equality. Okay, next, multiplication. Multiplication property of what? Multiplication property of equality. We say here, 3x is equal to 15. Okay, if 3x is equal to 15, then what? Then x equals 5. What happened? Now this one should be very familiar. You guys have done this many, many times. You took Algebra 1, geometry. Okay, so what happened? Okay, what happened? Notice you had 3x and 15. Now you have x and 5. Notice 3 was divided, 3 was divided. You have to fill this in your mind. Divide by 3, you see it. Okay, the 3's canceled. You have x equals what? X equals 5. Now we say that division is the same as what? Multiplication, so we call this the multiplication property of equality. All right, lastly, if x over 5 is equal to 4, then x is equal to 20. Okay, so again, fill in the blank. Notice 3 is being multiplied by x. How did we get rid of it? 3 was being multiplied. What did we do? We divided. Okay. Notice 7 was being subtracted, so we added. 5 was being added, so we subtracted. 3 was being multiplied, so what did we do? We divided by 3. Okay. Notice that 5 is being divided, so what are we going to do? We're going to simply what? Multiply by 5, and you see that we get what? X equals 20. The 5's cancel. Okay. So again, you have to fill this in your mind. It's not going to be written out. You're going to be given if x over 5 is 4, then what? X equals 20. All right, so you have to see 5 is multiplied, 5 is multiplied. Okay, so this is it in a nutshell. These are the properties, all the properties of equality, and you saw in the previous set the properties of the real number system. So hopefully this is clear. I encourage you to pause probably make a second video for the quiz. So go ahead and attempt your quiz, and then we'll look at what you did wrong. Okay?